class, and today we're going to talk about matter and energy and how they can change. So first I want to talk about the different types of change. So we have already discussed what a chemical change is. So a chemical change is when two or more elements or compounds create a chemically new substance. So everything that we've learned up until this point in time, most of it has been a chemical change. The other type of change that we have discussed is a nuclear change, where we have a change in the atom's nucleus. And there's usually a large amount of energy that is released in that. Today, what we're going to focus on is physical change. So first thing that we want to talk about with physical change is that we can have physical properties and so the different types of physical properties can be melting or boiling points. Their properties can also be color, texture. So anything that can be observed with the five senses. Those are what creates physical and chemical or physical properties. And when we talk about physical, when we talk about change, this is where the substance remains the same. And so if we have, let's say, salt and water, we mix them together, we can mix them together and it still is water and salt. It hasn't undergone an actual chemical reaction, so we could still separate out those. So under chemical change, we can have different types of things. So the first thing we can have is what's known as a mixture. So under a mixture, we can have heterogeneous. So this is where the objects are easy to see or separate. So that could be elements, it could be compounds, we can see it. An example of a heterogeneous mixture could be such as beach sand or a chocolate chip cookie. So you can easily see that there are different parts and they're not evenly distributed throughout. The other type of mixture that we can observe is known as a homogeneous mixture. So this is where the particles are evenly spaced, and often they are harder to see or separate. And one specific type of a homogeneous mixture would be a solution. So this is usually a solid dissolved in a liquid. So for a solution example, you could have salt, water. So looking at specifically physical changes, today we're going to focus on how matter can be affected by change in energy. And specifically talking about states of matter and change in energy. So some key things that we need to know about with energy, first of all, is that energy and temperature are two different things. So first of all, temperature is the measure of particle movement. So when particles move more rapidly, the temperature increases. When particles slow down, the temperature decreases. So we usually use for science, the main units of measure are going to be Kelvin and Celsius. So in Kelvin, our value here can go from 0 all the way to infinity. And so you cannot have a negative value for Kelvin. And for Celsius, we have it based on 0 degrees Celsius equals freezing water, and 100 degrees Celsius is boiling point for water. And when we want to do a conversion, the conversion rate for when we're dealing with Kelvin equals degrees Celsius plus 273. And if we want to convert from degrees to degrees Celsius, we would take Kelvin minus 273. So Celsius, the reason for the degree symbol means that it has been derived, and that's because it's based on the boiling and freezing point of water. So we can have a negative value for Celsius, but Kelvin can only be 0. And when we talk about absolute 0, this is talking about in Kelvin when particles stop moving. So again, that should be just a refresher. You should know what absolute 0 is. And it is a theoretical number. We have not actually achieved 100% absolute 0. That's because one thing, we wouldn't have a way to measure it since temperature is the measure of the movement of the particles. So if it stopped moving, we would have no way to measure that it has stopped moving. Another way that we can measure what's happening in physical change is using heat. So heat is the amount of energy absorbed or released from particles. And so heat, our units that we're going to be using to focus on for this are going to be joules, which is noted by a capital J, or we can talk about calories, and it's noted by a little cal. And something to note is our food is actually measured in kilocalories. So it's actually 1,000 calories equals that. So what exactly is a joule or a calorie? And how do we determine what is happening here? So we're going to use an equation which is about specific heat. And so specific heat is the amount of energy required to increase 1 gram of a substance by 1 degree Celsius. And so again, when we talk about calories in our food, they've used specific heat to help calculate those calories. So let's talk about what is specific heat. Specific heat, the unit So when we talk about the specific heat, the unit is C. So C is a constant value. And the unit for it can either be 4.18 joules per grams degrees Celsius. So remember that we said specific heat is the amount of energy required to increase a substance by 1 degree Celsius, 1 gram of that substance by 1 degree Celsius. We also can talk about it from calories, but we're going to focus specifically using joules. Okay, so we're going to talk about an equation for specific heat and energy. So how do we measure the amount of energy that it takes? And so here we're going to talk about that information here. And by the way, up here when I talked about the constant for specific heat, this is the specific heat for water. And so the value for specific heat changes by substance. So each substance is going to have a different value for specific heat. So our equation that we're going to need to know how to use and manipulate is Q equals mc delta T. And when we're talking about mc delta T, what does that represent? So our Q value equals the energy in the substance. So our energy usually in the form of heat. So energy can also be in the form of light or other ways, but we're going to focus on it with heat for this practice here or for this lesson. The next thing that we also need to look at is M. M equals mass. So the mass of the substance. The next letter we have, which is C, which is specific heat. And this is a constant value that is different for each substance. And then finally, we have delta T, which is the same thing as saying change in temperature. And so when we look at the change in temperature, what we're looking for is what is happening in our temperature final minus our temperature initial. And this is usually measured in the unit of degrees Celsius. And for specific heat, we usually are going to measure it in joules over grams degrees Celsius. Mass is going to be measured in grams, and energy is going to be measured in joules. So you have grams here, which is your G, joules, which is your capital J, and then your temperature is in Celsius. All right, so when we're talking about this heat equation and using specific heat, I do want to talk about what does it mean for our Q value. So we can have positive and negative energy, and keep in mind that energy is not necessarily a negative value, but it's the direction of the value. So a Q positive means that energy is flowing into the substance. So it is being absorbed. And when it is absorbed, we consider this to be endothermic. So the word endo meaning to enter. So it's absorbed, it is endothermic. If Q value is negative, then energy is flowing away from the substance. And we consider this to be released. And if it is released, it is considered exothermic. So to think of the word exit means to release or to leave. So energy is flowing away. So let's look at an example problem for the heat equation. So our first example is how much energy is required to heat 100.0 grams of H2O by 3 degrees Celsius. I'm going to put 3.0 degrees. Now it looks like 38. So 3.00 degrees Celsius. So the reason why I need to put these zeros is we're going to talk a little bit about how to calculate using sig figs also in this problem. So if you are in honors, you do need to know how to use sig figs. So first things that we need to figure out. So we are given a number of 100 grams. We're given 3.00 degrees. Looking at our equation that we had the equation of Q equals mc delta T. So in our problem here, this is going to be our mass of the substance. This is going to be our change in temperature. So we don't have to calculate the change in temperature. It's already given. And then what we don't have for us right now is our C value or our Q value. And in the question, it says energy. So this is our Q. So where do I find C? Well, I've given you C earlier when we talked about how it is a constant value. And so when we look at that constant value for the specific heat of water, we said it was 4.18 joules per grams degrees Celsius. So we can make a list of what we have. So Q is our unknown. M is equal to our 100.0 grams. And our delta T is equal to 3.00 degrees Celsius. And then our C for water is equal to 4.18 joules per grams degrees Celsius. Now all we have to do is solve for our unknown, which is Q. So for solving for our unknown Q, we're going to go ahead and plug in our information to our equation. So we have Q equals the mass, which is 100.0 grams, times the specific heat of water, which is 4.18 joules over grams degrees Celsius, and then our change in temperature, which is 3.00 grams. Now, when we add and multiply our information together, before we do that, let's just verify that we've set up our reaction or equation the correct way by making sure that our units cancel. So grams here, it's not on a division bar, so that means it's above, and grams is below the division bar, so they cancel. Degrees Celsius is here, and this should have been not grams, but degrees Celsius. So our degrees Celsius cancels, leaving us only with joules, which is the unit that we need to solve here. So 100 times 4.18 times 3 is going to give us a value for Q of 1254. And again, the unit that we have left over is joules. And since this is a positive number, I don't have to put the positive there, but I will. This is going to be an endothermic reaction because it is positive value. Now let's go ahead and take it a step further and let's talk about how this relates to sig figs. All right, so the first thing that we have to do when we are multiplying is determine the number of sig figs that we have. So when we look here, since we have these decimal spot here, that means all of those numbers are significant. So we have 4 sig figs. Here, temperature, we're given 3 significant figures. Then remember, this is a constant, and all constants have infinite number of sig figs. So this one is not going to determine how many sig figs that we have. So when we multiply or divide, we have to make sure that we are using the correct number of sig figs that are given in the initial problem. So since we only have 3 sig figs here, this number right now has 4 sig figs. So to make this rounded to the correct answer, it would become 1250 joules. And again, we're not going to put a decimal spot there because we need this to be 3 sig figs. We can also change the equation around where if we want to know what will be the change of temperature for an object if we know the energy that was required. And so in this example, I'm going to do change in temperature. And we're going to talk about lead for this example. So the specific heat for lead is a constant value of 0.160 joules per grams degrees Celsius. So our question is, what is the change in temperature if 400 joules of energy is released when 25.0 grams of lead is cooled. All right, so in this event, we have a new key term here. So we have 400 joules, but we have the keyword released. So because it's being released, this is technically a negative joules because it is an exothermic reaction. Remember, released means exothermic. And when it is exothermic, joules are negative. So let's look at what information we were given. So if our equation is Q equals mc delta T, we here are looking for the change in temperature. This we do not know the answer to. We also are given our energy and we are given our mass. So we can go ahead and plug this information into our equation. So we have negative 400 joules equals our mass, which was 25.0 grams, and then our C, which is given up above. So this is a constant value, and I would provide that for you on a test. So 0.160 joules over grams degrees Celsius. What we do not know is the change in temperature. So this is what we are solving for. So to be able to solve for this problem, the first thing we can do is we can go ahead and we can simplify this, or we can just divide both sides. So I'm just going to divide both sides by 25.0 grams and 0.160 joules over grams degrees Celsius. And then over on this side, we need to do it to the same side because we need it to go away from this side and come over here. So 0.160 joules over grams degrees Celsius. Now, what we can do is we can go ahead and simplify. So delta T equals negative 400 joules. And for sig fig purposes, I'm going to put a decimal behind this. So in the problem, I would have put 400 dot. And our bottom number is going to be 25 times 0.16. And so we get a 4. So if this is 400, and if I put a 4 here, since I have multiplied these, I have to consider the number of significant figures. So this one was 3, and this one was 3. So this number here, I'm going to put as 4.00. When we divide negative 400 by 4, we are going to get a number of 100. Right now, this number here has 3 sig figs, and this one here has 3 sig figs. This one currently only has 1 significant figure. So I need to put a dot there. Now, I didn't put the unit down below here quite yet. So we have grams that canceled, and our unit is joules over degrees Celsius. Now, our joules will cancel, and so our answer will be degrees Celsius. Now, notice this was a negative and this was a positive. So we can't say it increased by 100 degrees, but it actually decreased. So again, looking at our answer here, or our question, it says cooled. So we need a negative temperature. Let's look at another example. This time we're going to look at what is the mass. So what is the mass of water if the energy needed is 564 joules to change the temperature from 5 degrees Celsius, 5.00, we'll do 5.00 degrees Celsius, to 10.00 degrees Celsius. All right, so again, we need to look at our equation. So our equation is Q equals MC delta T. So what are we given? We're given temperature and a temperature. So the temperature is changing from, so this is our temperature initial, to our temperature final. We also are given our Q value here, which it is increasing. It's a positive value. And we need to find out our mass. So this is our X. And what we need to remember is that C for water, I gave that to you guys earlier, is 4.18 joules per grams degrees Celsius. So now we can go ahead and plug in our information again. So we have a Q value of 564 joules is equal to the mass, which is unknown. That we don't know. And our specific heat, our C value, is 4.18 joules over grams degrees Celsius. And then our change in temperature, we need to remember that delta T equals TF minus TI. So temperature final minus temperature initial. So we had 10.00 degrees Celsius minus 5.00 degrees Celsius. So when I look at this, I have 3 sig figs here, and I have 4 sig figs here. So I need to simplify based on order of the operation. So we need to solve for this part first. So that means I'm going to have 564 joules equals X times 4.18 joules per grams degrees Celsius. And then this answer would be 5, but based on the sig figs and the decimal location. So this goes to the 100th, and this one goes to the 100th. So this answer needs to go to the 100th, and the unit stays here, which is degrees Celsius. I now can go ahead and divide both sides by the same numbers here. So I have 4.18 joules over grams degrees Celsius times 5.00 degrees Celsius. And then over this side, 4.18 joules per grams degrees Celsius times 5.00 degrees Celsius. So again, looking at what cancels for units, joules are going to cancel and degrees Celsius is going to cancel, leaving me in grams, which is great because the question is asking for grams. So you can always double check that you've set up your equation correctly based on what unit you're left with before you solve. So X now is going to equal, so I've got 564 joules, and down below, if I take 4.18 and I multiply it by 5.00, I'm going to get 20.9. and I'm left only, this unit had already canceled, so I'm left only in grams, and it's per grams. So really the grams came up on top, because notice the grams are down below here. So it is just per gram. So when we take our 564 and we divide it by 20.9, we will get a value of 26.9856459 grams. And now we need to look back at our numbers here. So we had 3 sig figs here and 3 sig figs here. So this number needs to round to 3 sig figs. So this is where we're going to round to, is where this 9 is. But the number after is an 8, so this rounds to a 0. So what needs to happen is this needs to become 27, and that becomes a 0. That has to stay there to give us the 3 sig figs, and our unit is grams.